As you might have expected, I always use examples to explain like concepts instead of me giving you definitions and the technical meanings of them. I give you examples. So take this sequence: 2, 6, um, 18. Okay, sharp. This is a sequence. Can you guys tell me the next two members of the sequence? Can you guys tell me the next two members of the sequence? Someone says 54 and 162. The next person says, let's go to Tsepang Hui. What is the next two terms here? Yeah. Tlale? Thank you for that, Tlale. Okay. So now you guys are claiming that the next two digits are 54 and 162. Now let us see if that is indeed the case. So I gave you the sequence and I asked you guys to tell me the next two terms. So you look, how did I move? How did I move from 2 to 6? They could have either added a 4. Let me write it at the top. They could either have added a 4 or multiplied a 3. Okay, that is fine. How did I now move from 6 to 18? They could have either added a 12 or multiplied a 3. Feel it? How did I? Yeah. So what's gonna happen now is that they added a 4 here, they added a 12, they multiplied a 3, multiplied a 3. So the logical one would obviously be the multiplying by 3 because it is consistent. So therefore, for them to move between successive terms, they multiply 3. So for you to move from 18 to the next one, you'll have to multiply 3. 18 times 3 gives us 54. 54 times 3 gives us 50. 162, sorry. So this is how we go about it, right? So sometimes, as I always say, you may not see like at outset, like you may not see like immediately that they're multiplying 3 between successive terms. If you're doubtful in that regard, what you do is the pen stopped writing, come on. You go the next number divide by the previous number. So the next number is 6 divided by the previous number 2. Remember that over is the same as divide. You guys get it? And then this will give us an answer of how much? 3. Alright? I'm currently writing using my finger because the pen has stopped writing. So now this 3 means that for them to move from 2 to 6, they multiplied by 3. Very logical. Remember yesterday, with regard to the arithmetic sequence, we were minusing to check what they added. So, but when it comes to geometric, we divide to see what they multiplied to move to the next. I hope I'm making sense. If you don't see what they multiplied 3 to 6 so that they can get 18, you can just go 18. Next number divided by the previous gives you 3. Same thing here, 3, 3. Are you guys happy? Now, this type of sequence where they multiply the same number between successive terms is what we call a geometric sequence. I don't have to write the definition. You should also be able to say the definition in Sepedi or Setswana. Geometric sequence is one where do not cram, do not write anything down. You must understand it. It is one where you multiply or divide, if you like, divide the same number between successive terms, right? And it is constant, basically. Okay, let's do another example. I've got 1 over 2 um, um, 1 over 2 1 over 3 um, 2 over 9. Can you guys give me the next two terms? Yeah. So sorry. Charlie says 4 over 27, 8 over 81. I'm going to write it there at the bottom. I'm waiting for Bashali and Tungkweng to also tell me what they got. Okay, Sabang got the same, and then Bashali. Second. Almost done. Okay, okay. Take your time. Take your time. Take your time. Proper stuff. If all of you got the same answer, that means you guys are correct. So now I gave you this sequence, and I asked you guys to give me the next two terms. Now, in the exam, when you're given a sequence, right, they don't specify that it is an arithmetic or geometric, right? What you do first, right? The first thing you do in an exam, you wanna check if maybe they were adding in between successive terms, right? So how do you check adding? I told you it's minus, so it's gonna be uh, 1 over 3 minus 1 over 2, and that is minus 1 over 6. That means for them to move from 1 over 2 to 1 over 3, they went 1 over 2 minus 1 over 6. Okay, now you want to know what they did to move from there to there. You do the same thing. You go 2 over 9, the next number, minus the previous number, um, gives them it gives them an answer of minus 1 over 9. Now, since this is not constant, it tells you that it is not an arithmetic sequence. Then you stop and then you check for geometric sequence. What is a geometric sequence? One where they multiply or divide the same between successive terms. So that should always be the approach. So you want to find out what they multiplied 1 over 2 by to get 1 over 3. So just go 1 over 2 divided by 1 over 3. So sorry, 1 over 3, the next divided by the previous, sorry, gives you 2 over 3. Okay, that means this 2 over 3 means that for them to move from there to there, they multiplied 2 over 3. Let us find out what they multiplied in between the two for them to move from there to there. So it is 2 over 9 divided by 1 over 3, still 2 over 3. So now you clearly see what this thing is constant. This is what we call the ratio. The ratio, the number by which they multiply, is constant. So therefore, you can safely conclude that this is a geometric sequence. Fede? Now, for you to move to the next, from 1 to 9, you're gonna multiply 2 over 9. You're gonna multiply 2 over 9 by 2 over 3. It gives you 4 over 27. Multiply there, 8 over 81. All of us are happy there, yeah?